smart flood monitoring and alert system using ESP8266 NodeMCU. Hi everyone, my name is Dr. Konark Sharma. In this lecture, we will learn about the basic overview of an IoT-based smart flood monitoring and alert system using ESP8266 NodeMCU from Vanisha Rajtamar, Nishant Sharma and Sujul Kumar. Upon completion of this lecture, learners will be able to understand about the basic overview of an IoT-based smart flood monitoring and alert system using ESP8266 NodeMCU. So, let's get it started.
KONARK'S research. Subscribe now.
Good afternoon, sir. We are from team number 15 and our project is flood monitoring and alerting system. My name is Vanisha and I have worked upon alert portion of our project.
Sir, my name is Nishant Sharma and I have worked upon software and coding part of our project.
Sir, my name is Sujul Kumar. I have worked on hardware component and also performed testing of our project.
So basic introduction to our project, flood monitoring and alerting system. Floods are among the most devastating natural disasters causing significant loss of life, property and infrastructure. Early detection and timely alerts can play a critical role in mitigating the impact of floods. Our project is designed to address this challenge by using modern technologies to monitor water levels in real time and provide alerts when critical thresholds are reached. Our project combines hardware components like ultrasonic sensor, LEDs, buzzer, LCD display and a microcontroller with software integration using Twilio's SMS API for remote notification. Our system continuously monitors water levels using an ultrasonic sensor and provide visual, auditory and SMS alerts to warn user of potential flood risks. Basic objective of our project is to design and implement a real-time flood monitoring and alerting system using NodeMCU to enhance disaster preparedness and response. Our system aims to continuously monitor water levels using sensors and provide timely alerts through the Internet IoT to help mitigate flood risk. By integrating cloud-based notification and automated data transmission, our system will aid in early detection of potential flood risk, allowing authorities and individuals to take appropriate preventive measures.
Let us talk about workflow of our project. Step 1. Sensor collects the data, that is water level. Step 2. Data processing. The microcontroller processes sensor data and compare it against predefined threshold. There are 3 levels: normal, warning and danger. Alert through LED. Green LED light up for normal level, blue LED light up for warning level, red LED light up for danger level. Step 4. Auditory alert. The buzzer produces sound alert when the water level reach up to the maximum height. Step 5. Display output. The LCD provides real-time data, that is current water level in centimeter. Step 6. Alert mechanism. An SMS message is sent to the registered mobile number. Step 7. Continuous monitoring. The system continuously monitors water level, updating output.
Now it's time to understand that how our solution is better than the existing solution. First, real-time monitoring. Unlike manual inspection, our system provides a continuous water level update for immediate detection of potential flood. Cost effective. Using NodeMCU make our project much cost effective as compared to the existing flood monitoring system which use a multiple radar. Third, automatic alert. Sending alert by SMS whenever water level cross the threshold limit. Improve the response time and reduce the human interval. Fourth, customized threshold. Water level threshold for alerting can easily customize based on location and specific requirement. Fifth, compact and portable. Our system is very compact and portable due to its design, and it's very easy to install it anywhere with simple guidance. Sixth, power consumption. Our system provides very low power consumption and it's very energy effective. Seventh, due to multiple sensors, it provides high accuracy.
Let us talk about hardware component of our project. First one, NodeMCU. It acts as the microcontroller to process data from the ultrasonic sensor and control output like LED, buzzer and LCD. It supports Wi-Fi connectivity for IoT-based alert. Arduino is ideally for basic monitoring system without wireless connection. Second, ultrasonic sensor. Its function is to measure water level by calculating the distance between the sensor and the surface. Its working principle is that the emit ultrasonic waves via track pin and the measure the timetable for the wave to bounce back to the echo pin. Third one, breadboard. Its function is to provide a platform for connecting component. 4. LED. Green LED indicate for normal water level. Blue LED signal warning level approaching danger. Red LED alert critical danger level. Buzzer. Its function is to emit sound alert to the warn user of rising water level. 16:2 LCD display. Its function is to display real-time information such as current water level in centimeter or percentage. These components work together to monitor water level, provide timely alert, and display relevant information, ensuring an effective flood monitoring system.
The alert mechanism of our project is designed to notify users when water levels reach critical thresholds, helping them take necessary precautions before flooding occurs. Let's talk about an explanation of how the alert portion works. First is triggering conditions. When the water level crosses predefined thresholds, the system activates the alert mechanism. There are two levels, that is warning level and danger level. Warning level indicates approaching danger and danger indicates signals of critical flooding conditions. Second is visual alerts, that is LED are used to visually indicate the status. There are three LED, green, blue and red. Green light shows the normal water level, that is safe condition. Blue LED shows the warning level, that is approaching danger, and red LED shows the danger level, critical flooding. Third is auditory alerts. A buzzer is activated for auditory warnings. And fourth is SMS alerts via Twilio. That is, Twilio is integrated into our system to send SMS alerts to registered phone numbers. Steps in Twilio integration: when water level exceeds thresholds, the microcontroller triggers Twilio's API, and Twilio sends an SMS containing information about the current water level and flood status to the recipient mobile number. And this provides a real-time monitoring to the system and updated alerts dynamically based on sensor readings. If water level returns to safe condition, an all clear SMS can be sent using Twilio.
Now let us understand the coding part of our project. We have used ESP8266 Wi-Fi.h module, which is used for handling Wi-Fi connectivity for NodeMCU. We have used ESP8266 HTTP client.h library, which is used for managing HTTP request for Twilio API. We have used Wi-Fi client secure.h library, which is used for providing SSL or TLS for secure Twilio API calls. We have used wire.h library, which is commonly used for enabling I2C connectivity for the LCD. We have used liquid crystal I2C.h library, which is specially used for controlling 16x2 display library and display with I2C. It means to control to coordinate with the I2C module and 16x2 display, we use this library. We have used base 64.h library for encoding Twilio, and this is the Wi-Fi part of a project, that is this is SSID, which is simply the Wi-Fi name and Wi-Fi password. And here we have 4 main character for our 4 main part of to get SMS. This is account SSID code, this is auth token, and this is Twilio number from where we receive the SMS, and this is number where we have to receive SMS. Since we know that the sensor has 2 main part, from where it receives or give us a message, the result. It is trigger pin and echo pin, which is connected with D1 and D2 part of our NodeMCU, and similarly green light it connected with D5, yellow with D6, red with D7, and buzzer with D8 part of a NodeMCU. And if we further see our main part of our project, that is this is a part for measuring distance of ultrasonic sensor, and this is for calculation of distance. And here is our conditions, that if distance is more than 10 centimeter, then green light will high, more than or equal to 10 centimeter, then green light high, yellow light low, red light low, and buzzer low, and the send SMS is a function or is a statement which will be false, which we can see here that if send SMS it is true, then this part will be activated, and this part will be activated and we will receive the SMS. So currently it is false, and if the distance is between 10 and equal to or less than 5 or more than 5, then green will low and yellow will be high. It means blue will be high, sorry, and it is written here yellow, but currently in our project it is blue, and red will be low and buzzer will be low, and SMS sent it will be false. It means we will not receive any SMS. And if the distance is less than 5 cm, that is 4 3 2 1, then green will be low, yellow will be low, and red light will be high, and this time buzzer will also be high. And in all this condition we will get danger, and here will be danger and other will be get distance. So, and this is the SMS part of our project, SMS code of our project. So now let's see the working model of our project. So our whole setup is here, and here we see the water tank. So currently the water level is between 10 to 5 centimeters, so blue light is glowing and distance is presenting here. Let's see the serial monitor, and we can see the live distance of water level currently here 6 centimeter, 6 centimeter, sorry, 6 centimeter. So let's increase the water level and see what's happened. So here is my phone, and we are increasing the water level. You can see the distance here. Now the water level is 5 centimeter, and we add few more water. Now the water level hits the 5 centimeter threshold. It means that water level is currently less than 5 centimeter. So here is my phone, and we see a message that is water level less than 4 centimeter. And if we increase the water level, for example, here we increase the distance of sensor, we can see that water level becomes normal. And if the distance further increase between 10 or infinity, then it will be green light will glow. So let's see the component. You can see 340 centimeter. It's enough. So let's see the working model or our components. So it is our ultrasonic sensor which we are using for water distance measuring. And here we are. So here we are using Arduino. It is because of we want 5-volt input for a proper working of LCD and ultrasonic sensor. We have used a NodeMCU. We have used it because it's faster than Arduino. Its space is more. It have 4 MB of space, and it is having a Wi-Fi module, which is our main requirement for SMS. And we have used there I2C module. We have used to reduce the complexity of our model. And here is buzzer. You can see here it's buzzer. If we decrease the water level, you can see buzzer starts and the light glow, distance showing -5 cm, less than 5 cm. And here also we can see the current live distance, that is less than 5 cm. Thank you.
Conclusion of our project is that it is an efficient and reliable solution for real-time monitoring of water levels and providing timely alerts to prevent flood-related disasters. Our system is scalable, cost-effective, and can be adapted for various applications like river monitoring, water tank management, or disaster preparedness. In conclusion, our project demonstrates how technology can be utilized to enhance safety and mitigate risk associated with flooding, contributing to smarter disaster management solutions. Thank you.
Finally, we would like to cooperate with you according to the best of our knowledge. Keep your feedback and suggestions coming. They help us to provide you quality work that resonates with your needs and requirements. Thanks much for sharing your kind suggestions. Keep healthy, keep learning, and keep growing.
KONARK'S Research. Subscribe now.